if we look at problem 1, it says that we have a large fish tank that has developed a leak. It says it originally contained 15,900 gallons of water. However, it's losing water at a rate of 36 gallons per minute. Which of the following equations below gives the amount of water in gallons, W, in the tank as a function of time, which is T, in minutes after the tank developed the leak? So our initial start is 1,500, or 15,900. So that's going to be my start value. So I can go ahead and cross out A and B because my start values are not 15,900. Now from here it says that we're losing water at a rate of 36 gallons per minute. So that means for every minute we're going to subtract 36 gallons. So that means my slope is going to be negative 36, which means it's not D, so my answer is C. Problem 2 says that Jolie is planning to invest $2,589 in a savings account which pays a 6% compounded interest annually. What type of function approximately models the situation? When we're talking about a compounded interest annually, we're talking about an exponential equation. So I know I can mark out A and I know I can mark out D. Now, when you're being paid a compounded interest annually, that means you're getting paid more money. So that means that your final cost is going to increase. So if your amount of money that you have increases, then you're going to have an exponential growth and not a decay. Problem 3 says that a particular strain of bacteria reproduces every 3 hours. If 8 bacterial cells are placed in a Petri dish, how many bacterial cells will there be in the dish after 18 hours? So from here, we have to create a exponential equation because it says we're reproduce every 3 hours. So that means if I start off, in this case, 8 bacteria cells, I'm going to have 1, 2, 3, 4, 5, 6, 7. I have 8 bacteria cells. From here, after 1 hour, I have 8. In 3 hours, they all reproduce. So they're just going to double. So in 3 hours, I'm going to have 16. In 6 hours, because it says every 3 hours, I'm going to double again. So that means I'm going to have 32. Now, since it reproduces every 3 hours, and they want to know how many bacteria cells I'll have in 18 hours, I have to take 18 and divide it by the number 3. So that 18 divided by 3 is 6. So when I'm writing my formula, I'm going to have A sub n equals my initial start value, which is represented as A sub 1, times R to the n minus 1 power. So I'm going to have A sub n equals 8, because A sub 1 is my start value, times R, which is where I get 16 divided by 8, which equals 2. So I'm going to put 2 in for R. And we're looking after 18 hours, but remember, we have to take 18 and divide by 3, which is 6. So I'm going to have 6 minus 1. When you plug this into the calculator, your final answer should be C, 512. Problem 4 says, a company gives yearly raises to their employees. The salaries at the company are based on the equation below, where S is the salary before taxes and T is the time since the date of hire in years. What is the minimum number of years an employee would have to stay to make over a salary of $400,000 per year? So S is the salary and T is the time. they're giving us our salary. So 40,000 represents S. So I'm going to have 40,000 equals 33,113 plus 600 T. So I'm solving for T. So I'm going to subtract 33,113 from both sides. Which gives us 6,887 equals, because those cancel out, 600 T. Because I'm multiplying 600 by T, I have to divide both sides by 600. So that T equals 11.5. Because we're wanting to make over 40,000, I have to round this number up. So my final answer is going to be C, 12 years. Problem 5 says Melissa is learning to cook cupcakes for the first time. On her first attempt, she made 2 dozen cupcakes in 5 hours. On every subsequent attempt, she spends 5/6 of the time previous to make the same number of cupcakes. What type of function approximately models this situation? So, because she starts off at 5 hours to make the same 2 dozen cupcakes, if she spends 5/6 of 5 hours, she's going to spend about 4.6 repeating. And then if she spends 5/6 more of that, she's going to have 3.472 repeating. And then so forth until she gets really good at making these cupcakes. So if you look, the number that I'm decreasing by changes every time I decrease. So I know it can't be linear. And I don't have a number in the middle that's surrounded by repeating numbers. So I know it can't be quadratic. So that means it has to be an exponential. Now, look if my numbers are increasing or decreasing. To get from 5 to 4.16, I'm decreasing. So that means I have an exponential decay and not a growth. Problem 6, it says a holding company is having a dinner reception in a hotel ballroom. The graph represents the total cost of the ballroom rental and dinner. Which function represents the data displayed in the graph? So if you will agree with me, I have a linear equation. I know this is linear. The equation for linear is y equals mx plus b. M is my slope. So I know a point that I can adequately identify is here. And another one I can adequately identify is here. So M is my rise over run. So this point starts off at 7. So to get from 700 to 850, I have to do 850 minus 700 divided by 10, and 30 are my x values, so I have to do 30 minus 10. So 850 minus 700 is 150. 30 minus 10 is 20. So in your calculators, if you do 150 divided by 20, gives you 7.5. So in front of the x, I should have 7.5. So y equals 7.5x plus my y-intercept, which is a little under 650. So I would probably say about 625. So which one of these equations look like my equation I have written? The answer would be D. Problem 7 says that the table below represents a linear situation. So you use this table to construct the function as it represents. Okay, linear representation. So that means I'm going to have y equals mx plus b. To find my m, I have to find my rate of change. So I'm going to do negative 12 minus negative 10. The negative 10 becomes a positive because it's a minus a negative. So negative 12 plus 10 is negative 2. So my slope is y equals negative 2x. Now, to find my y-intercept, because b is my y-intercept, I have to go backwards to 0. So if I go backwards from subtracting 2, now I have to add 2. So at 5, I would have negative 8, 4, negative 6, 3, negative 4, 2, negative 2, 1, 0, 0, 2. So that my final answer is going to have y equals negative 2x plus 2. So in this case, my answer is going to be B. Eight says the graph below represents the bacteria population after t minutes. Construct the function which represents the data displayed in the graph. So since this is an exponential growth, I'm going to have y equals a times b to the x power, where a is my initial start value and b is my common ratio. So if we look at our graph, I can see a point at 1, 200. And I see another point at 2, 800. So about right there. Remember, when we're finding the common ratio, we have to take my second y value, which in this case is 800, divide by the previous number, which is 200. 800 divided by 200 gives me 4. So I'm going to plug in 4 for b. So I'm going to have y equals 4 to the x power. Now if we look, my y-intercept, because a is my y-intercept, is right here. So if each of these little tick marks represents 100, I would say that line is probably halfway between 0 and 100. So it's about 50. So I'm going to plug in 50 for a. If I look at my equations, the one that looks just like this equation is going to be a. So a is my answer. Problem 9 says, in an organism whose environment does not affect the cell division, a parent cell divides into 2 daughter cells. Those 2 daughter cells each divide into 2 more cells for a total of 4 cells. If those 4 cells divide into 2 more cells, there will be 8 cells in the organism. If each of these cells continue to divide in the same manner, how many cells will be in the organism after 15 divisions? So anytime that we're doubling our cells, because we start off with 1, then we go to 2, and then 4, and then 8, that means we're doubling. So I know this is going to be an exponential equation. For this problem, I'm going to use a sub n is equal to a sub 1 times 2, times r to the m minus first power. So a sub 15, because we're looking for the 15th division, is equal to my start value. So we have one cell as my start value, and my common ratio is 2. And then I have to have 15 minus 1. So my final answer is going to be A, 16,384. Problem 10 says that the decay of an isotope is represented by the graph below. It says about how many grams of the isotope will remain after 30 days. So from here, I have to create another exponential equation because my graph only goes to 12 and I'm looking for 30. So I'm going to have, I'm going to use y equals A being my starting y-intercept, which is 400, times B. So I'm going to take 340 and divide by 400 because I have to take my second y and divide by my first. So 340 divided by 400 is 0.85. And then I'm going to put 30 as my exponent. So if I take 400 and I multiply that by 0.85 to the 30th power, I get 3.05. So my answer is C. Problem 11 says, which function family should be used for the following question? The net profit of a certain company is calculated. It is found that the profit earned triples every year. If the profit at the end of the first year is 8 million, how much profit will the company earn after 3 years? So if it triples every year, that means that the difference is going to change every year. So I know it's not going to be linear. And if it triples every year, then it'll never decrease. It's always going to increase. So I know it can't be a quadratic function because a quadratic function will it'll decrease and then increase, or it'll increase then decrease. So I know it can't be a quadratic. Now, an absolute value function is going to look graph like this. It's going to be a V. So that also decreases and then increases, or increases then decreases. So it can be absolute value. So that means that this example is going to be an example of an exponential function. Problem 12. Celia has set a goal to raise $2,000 for her favorite charity this year. She has decided to participate in a walkathon to help her reach her goal. She found 30 sponsors, and each sponsor has agreed to give her 25 cents for each mile that she's walked in the walkathon. Which of the following functions shows the remaining money that she needs to raise this year, G, as a function of the number of miles that she's walked in the walkathon, M? So our starting goal is to get $2,000. For every mile that she walks, she's getting paid 25 cents. So for every mile she's walked, her goal is decreasing. So I'm going to subtract 0.25 M. Alright guys, so I'm so sorry. I just realized I made a little bit of an error. If we read back over the problem, she has 30 sponsors that's going to give her 25 cents each for each mile. So that means instead of putting 25 cents right here, I have to take the 30 sponsors and multiply it by the 25 cents to see how much she's actually getting for each mile. Because I have 30 sponsors that's giving me 25 cents per mile, I have to multiply 30 by 25, which gives us 7.5. So for each mile she's walked, she's getting $7.50. So this is the equation we have to have. So every mile she walks, she's subtracting $7.50 from her $2,000 goal. So my answer is going to be A. Problem 13. Mike invests $15,000 in a savings account which pays a 6% compounded continuously. Consider the following formula where A is the ending account balance after T years, and P is the initial amount of money invested, and R is the interest rate. How much money would he have in his savings account after 4 years? So he invests $15,000, and T is the initial amount. So I'm going to have A equals my initial amount of $15,000 times the 2.71 ratio to R is my interest rate. So this is 6%. So my interest rate is going to be 0.06 because I have to change the percent to the decimal. So I move the decimal places 2 places to the left. So this is going to be 0.06 times my T, which is 4. So if you plug this into your calculator, you're going to get roughly $19,054.78. Problem 14, it says to use the table. Construct the function which represents the data from the table. So if we look at this, I can automatically tell that this isn't increasing by the same amount each time. So I wanted to see if it divides by the same amount. If I do 777 and divide by 259, I get 3. And then if I take 777 and multiply that by 3, I get 2,331. And if I keep multiplying, I'll realize I'm just multiplying by 3 every time. So that means I'm going to use y equals a times b to the x power. A is my start value, so I'm going to have 259. B is what I get when I divide 777 by 259, which we said was 3 to the x power. So my answer is going to be C. Problem 15. Caleb is beginning to plant an orchard of orange trees. The number of orange trees he will plant each week during the spring is represented by the table below. If the pattern continues, how many orange trees will he plant during the 7th week? So I automatically realize it's not being added by the same thing, so I know I'm going to have to use my y equals a times b to the x power. A is my initial start value, but I'm not given a 0. So to figure out how to get to 0, I have to take my second number and divide it by my first. So 3 divided by 1 is 3. So instead of multiplying to get to 3, to get back to 0, I have to divide. So 1 divided by 3 is 1/3. B is 3. And then x, we're going to put 7. So if I plug this into my calculator, I'm going to do 1 divided by 3 in parentheses times 3 to the 7th power. Gives me 729 orange trees. 16. The population of a small town P has a function of time in T years that past 1940. Past 1940. That's going to be key in a minute. Which of the following years was the population of the town 12,228? So I'm going to set 12,228 equal to 2103 plus 375 T. I'm going to solve for T. So I got to subtract both sides by 2,103. So 12,228 minus 2,103 gives me 101.25 equal to 375 T. If I divide the 101.25 divided by 375, I get T equals 27. This is 27 years past 1940. So I have to take 1940 and add 27 years to it, which gives me the year 1967. 17. Use this table to construct the function that it represents. If I notice, to get from negative 9 to negative 4, I'm adding 5. To get to negative 1 to 4, I'm adding 5. From 1 to 6, I add 5. Because I'm adding the same number each time, I know I'm going to use the function y equals mx plus b. My m is my rate of change or my slope, so it's going to be 5x plus my y-intercept, which in this case is 1. So my function is going to be b. 18. For the experiment, Sarah puts 30 milligrams of salt into a glass of water to see how quickly the salt dissolves. What type of function approximately models this situation? So we're trying to see how fast the salt dissolves. The answer to this question is D. And the reason being is because each gram of salt dissolves at a different rate. Then none of the salt dissolves at the same rate, so it all dissolves differently. So it's going to dissolve, so that means it's going to decrease at an exponential rate. (19) says, express the terms of the following geometric sequences by giving an explicit formula. If I look, I'm not adding or subtracting the same amount each time. So it's not going to be an arithmetic sequence. So let me check if it's a geometric sequence. 4 divided by 1 is 1. 4 divided by 1 is 4. So each time I'm dividing the previous number by 4 to get the next one. So 1/4 divided by 1 divided by 4 is 1/4. 1/4 divided by 4 is 1/16. So yes, this is a geometric sequence. So I'm going to use the form a sub n is equal to a sub 1 times r to the n minus 1 power. A sub 1 is my first term, so I'm going to have a sub n is equal to 4. My common ratio is 1 divided by 4 to the n minus 1. So my answer is going to be B. Problem 20 says that, what are the first 4 terms of the sequence defined by the following equation? All I'm going to do here is plug in the numbers 1, 2, 3, and 4 into n to see what I get. So 5 times 2 to the 1 minus 1 power gives me 5. So I know it can't be A and I know it can't be B. So if I take my formula and do 5 times 2 to the 2 minus 1 power, I get 10. Well, both of those numbers go to 10. So if I do the same thing and do 3 minus 1 power, I get 20. So my answer is going to be D. 21. Identify the correct form of the following geometric sequence. It even tells you it's a geometric sequence, so you're going to use a sub n is equal to a sub 1 times r to the n minus 1. My first term is 7. I'm going to have 7. 56 divided by 7 is 8. So my common ratio is 8 to the n minus 1. So in this case, my answer is going to be C. 22. Express the terms in the following geometric sequence, so geometric sequence, recursively. So this one is where we're going to use the form a sub n is equal to a sub n minus 1 times my common ratio, and we have to list what a sub 1 is. So I'm going to have a sub n is equal to a sub n minus 1. My common ratio is going to be 4 divided by 2. 4 divided by 2 is 2, and my first term is 2. So my answer is going to be B. It's okay if the 2 is written out front. That is absolutely okay. 23. Express the terms of the geometric sequence by giving the explicit formula. So that means I'm going to use a sub n is equal to a sub 1 times r to the n minus 1. A sub n equals my first term, 7. 28 divided by 7 is 4. So 4 to the n minus 1. So my answer is going to be A. What are the first 4 terms of the sequence defined by the following equation? So I'm looking at number 24. Here again, the first 4 terms. So I have to plug in 1, 2, 3, and 4 until I find my answer. So if I plug in 1 for n, 1 minus 1 is 0. Anything to the 0th power is 1. So my first number should be 6. So I know it can't be C. So if I plug in 2 into my exponent of n, I get 0.06. Well, I know it can't be A, but it can still be B or C, or B or D. So I have to do the same thing, but instead of plugging in 2, I plug in 3. So I'm got 0.06. So it can't be B, so my answer has to be D. So all you're doing is taking these 4 numbers and plugging it into n until you find your correct answer. 25. Express the following terms of the geometric sequence by giving an explicit formula. Remember that explicit formula is a sub n is equal to a sub 1 times r to the n minus 1 power. Geometric sequence. My first term is 6, so I'm going to have a sub n is equal to 6. My common ratio is negative 30 divided by 6, which gives me negative 5 to the n minus 1 power. So if I look back, my correct equation is going to be D. 26. Express the terms of the following geometric sequence by giving the explicit formula. I'm going to have a sub n is equal to a sub 1 times r to the n minus 1. A sub 1 is my first term, so a sub n is equal to 4. 20 divided by 4 is 5 to the n minus 1 power. So for this problem, my answer is going to be C. 27. Find the 6th term of the following geometric sequence. I'm going to write this as an explicit formula, so I don't have to just keep writing my blanks. So a sub n is equal to a sub 1. A sub 1 is my first term, so 2. My r is found by dividing 8 divided by 2, which is 4. N is the term I'm looking for, so n is 6. So I'm going to have 6 minus 1. So 2 times 4 to the 6 minus 1 power is 2048. Problem 28. Determine whether the function below is even, odd, or both. Even, odd, or neither. For this example, pull this out. I'm going to have x plus 2 times x plus 2. Remember, the full method. Multiply your first numbers together. So I'm going to do x times x. I get x squared. O, multiply my outside numbers together. X times 2 plus 2x. Multiply my inside numbers together. 2 times x plus 2x. Then multiply my last numbers together. 2 times 2 gives me 4. Combine like terms. X squared plus 4x plus 4. Now, to determine if something's even, odd, or neither, or both, I have to look at my exponents. My exponents of my first variable is 2, so this is 2. My exponent of my second one is 1, And then the exponent of a constant number is x to the 0th power. So in this case, it's 0. In order for the function to be even, you have to have all even exponents. So I don't have all even exponents because of the 1. In order for my function to be odd, I have to have all odd exponents. But I have 2 and 0, which are even. So that means that my function is neither an even nor odd. So it's B. Alright. Question 29 says, which type of graph below? Is it even, odd, neither, or both? In order for a graph to be even, you have to be able to fold it along the y-axis and it look the exact same on both sides. If I fold this along the y-axis, I would get something that should look like this. And I don't. So this is not even. So I know it can't be A. But it is a function, so I know it can't be B, C. Now, if it's an odd function, that means I can take my graph, it goes through the origin. So it does go through the origin, and if I rotate it 180 degrees, it'll look the exact same. If I rotate this graph 180 degrees, which means you just flip your paper over, then it would look the exact same. So my answer is going to be D, odd function. Problem 30 says, what type of graph below? If I fold this along the y-axis, it will not look the same on both sides. So it's not even, so it can't be C. And it's a function because if I do the vertical line test, my function doesn't cross it twice. Odd. If I rotate this 180 degrees, will it look the same? No. And plus, it does not go through the origin, so it can't be odd. So my answer is going to be B, neither even nor odd. And that's it for the study, guys. Good luck, guys.